Okay, let's talk about metamorphic facies. When I was talking about the Barovian sequences, I was talking about index minerals, characteristic minerals that form in metamorphosed mudstones. The metamorphic facies is defined in terms of characteristic mineral assemblages that are observed in metamorphosed mafic rocks. So we typically talk about metabasites, metamorphosed basalts, and then the different metamorphic facies correspond to the different mineral assemblages that we would observe in that rock if it were metamorphosed at a particular pressure temperature condition. So here again, a pressure versus temperature diagram. If you had a mafic rock that was metamorphosed in this PT region, it would have a mineral assemblage characteristic of the blue schist facies. If you had a basaltic rock that was metamorphosed at this PT condition, it would have a mineral assemblage characteristic of the eclogite facies. And similarly here for the amphibolite facies, green schist facies, prehnite, pompelliite, granulite, and so on. What are those mineral assemblages? Well, there's a whole long list. I realize it can get very complicated very quickly. So I've taken this table, it's actually from Winter's textbook, and I've taken each of these facies and I've highlighted the really characteristic minerals. So the zeolite facies, characteristic minerals are zeolites. These are specific zeolites, but in general, it's sufficient to know that the zeolite facies is characterized by zeolite minerals. Prehnite pompelliite facies is characterized by prehnite and pompelliite, not surprising. Green schist facies is characterized by green minerals, chlorite, epidote, and at higher temperatures, actinolite. There can be lots of other minerals in here. There can be albite, very typically. There can be quartz, but it's really these green minerals that I focus on when I'm looking at rocks, either in hand sample or thin section. The amphibolite facies is characterized by hornblende. It always has a feldspar associated with it. Usually it's an intermediate composition feldspar. If it's an iron-rich rock, it can have garnet. A lot of these will have biotite if there's any potassium and so on and so on. Lots of different minerals, but the characteristic mineral here is hornblende. Granulite facies is defined by the occurrence of orthopyroxene, and it can have lots of other minerals. Clinopyroxene, misspelled I realize. Plagioclase is very common. If it's more iron-rich, it can have garnet. If it has enough water, it can have hornblende. But it's really the occurrence of orthopyroxene that defines granulite facies. The blue schist facies is characterized by the blue mineral glaucophane. At low temperature, it will have lawsonite. At higher temperature, it will have epidote. And it can have albite and chlorite and so on. But it's really this glaucophane that's important for identifying a rock as a blue schist. And then the eclogite facies contains garnet and amphissitic pyroxene. Amphissitic pyroxene has a high sodium content, and that's characteristic of high pressures. So what do these minerals look like? This is what zeolites look like. This is a basalt that has vesicles that have been infilled with zeolites. This is what it looks like in thin section. Here's some other zeolites. And here is what zeolites look like as they are metamorphosed. So this is a vesicular basalt from the Himalaya that was then metamorphosed. And all of these zeolites, which, if you recall from a previous lecture, have compositions very similar to feldspars, are metamorphosed and turn into feldspar. This is all plagioclase. Prehnite and pompelliite. Here's a nice image of prehnite. Here's what it looks like in thin section. And here's pompelliite, which typically has these radiating sprays. Here, this is a vesicle that has been filled in with prehnite and pompelliite. Pompelliite is this green mineral, and prehnite is the less colored mineral in here. Chlorite, actinolite, epidote, these are the characteristic minerals of the green schist facies. So here are dark green flakes of chlorite with prisms of actinolite. Here's some beautiful epidote. In thin section, this is epidote growing around here. You can see it has very high relief, and when you cross the polars, it has these intense interference colors. Hornblende, black crystals. So here's some black crystals of hornblende. Here is an amphibolite, black hornblende, white plagioclase. This must be iron-rich because it has so much garnet in it. And in thin section, we see moderate green crystals of hornblende. And there are lots of other minerals that can occur: epidote, titanite, plagioclase, apatite, so on. But the really characteristic mineral is hornblende. Higher pressure minerals, glaucophane and amphicite, these dark crystals are glaucophane. They actually have a very slight blue color. You'd have to see that in hand sample in the sun to be convinced of that, I think. Here is a blue schist, again, blue glaucophane. These light crystals are lawsonite. And here's a picture of a garnet blue schist. So there's a little bit of garnet, but this blue is blue amphibole. The white crystals here are lawsonite. And here again is another thin section photomicrograph with a big garnet, phengite, epidote, and this nice purple crystal here is glaucophane. Amphicite is the green mineral in this rock, and the red mineral is garnet. So this is a classic eclogite, the garnet plus amphicitic pyroxene. Okay, quick question. What minerals would you expect in a blue schist? And the answer is blue glaucophane and either lawsonite or epidote. Again, a blue schist is blue, glaucophane is blue. Another question, what minerals might you expect in an amphibolite? And here the answer is hornblende and usually plagioclase. So at this point, I hope that you'll be able to say something about where and how metamorphic rocks form, something about metamorphic mineral assemblages and how they reflect conditions, and also to have some facility with metamorphic isograds and index minerals in metamorphosed mudstones, and then the characteristic mineralogy of the metamorphic facies. All right, thanks.